For the first time since 2020, China's reclaimed the world's fastest supercomputer title, and it's not just a minor upgrade. The Lineshine system is a massive technological leap that's fundamentally reshaping the global race for computational dominance. Here's the thing. Supercomputers aren't just enormous machines humming in a lab somewhere. They are the engines that power every breakthrough we see in artificial intelligence, climate science, drug discovery, and materials research. Think of them like the ultimate problem-solving machines. They can process more information in a single second than most of us will see in an entire lifetime. When one nation dominates this space, they gain an enormous head start in artificial intelligence development, medical breakthroughs, and military simulation technologies. The exact fields that'll decide which countries lead the world in the next 10 years. The Lineshine isn't just sitting at the top of a leaderboard. It represents a fundamental change in who controls the computational infrastructure that shapes our technological future. China spent years falling behind after the United States and Europe dominated supercomputer rankings, and now they've clawed their way back to the top. What's remarkable is how fast this happened. And here's what most coverage is getting wrong about this. To understand why this announcement truly matters, you need to know the backstory. Supercomputers have been like the Olympics of computing, a race where nations compete for bragging rights and geopolitical status. Back in the early 2010s, China wasn't even in the global conversation about advanced computing. The United States basically owned the rankings, with systems like Titan and Jaguar dominating year after year. The technological gap felt insurmountable. But then something shifted fundamentally. China realized that to compete in artificial intelligence and scientific discovery at the world's highest levels, they needed serious computational muscle. So they started investing heavily, billions of dollars, into domestic supercomputer development. By 2016, China broke through spectacularly with the Sunway Taihu Lite, a completely homegrown system that shot to #1 globally. That was huge. It was a statement that China could build world-class technology independently without foreign assistance. For a few years, China and the United States played leapfrog, trading the top position back and forth. But the United States pulled ahead again around 2018 and held onto it for years while China's efforts stalled. Many observers thought the United States would stay dominant for another decade. Now, suddenly, China's back. But here's what the headlines aren't telling you. So what makes the Lineshine so incredibly fast? It's not just one thing, it's a combination of cutting-edge hardware and smart engineering. Think of it like the difference between a regular car and a Formula One vehicle. They're both cars, but the race car is built with every component optimized for pure speed. The Lineshine uses advanced processors, massive amounts of memory working in perfect synchronization, and interconnects that let different parts communicate at blazing speeds. It can perform over 100 petaflops of calculations per second. That's 100 million billion operations every single second. To put that in perspective, if your personal computer does about 1 billion calculations per second, the Lineshine is roughly 100,000 times more powerful. It's also incredibly efficient, which matters because these machines consume enormous amounts of electricity. A less efficient supercomputer might need twice as much power to do the same work. China also focused on using components they could manufacture domestically, which gave them more control over the design and supply chain. That's strategically critical. They're not dependent on anyone else for critical parts. The system architecture is specialized for the kind of mathematical problems artificial intelligence systems face. And that specialization is exactly what gives it the edge. But this leads to something really important about real-world applications. Now you might be wondering, what actually uses a supercomputer like this? Well, the list is incredibly long. Artificial intelligence training is one of the biggest ones. Modern AI models require enormous computational resources to train. When you're teaching a neural network to understand language, recognize images, or make predictions, you're essentially running billions of mathematical operations. A supercomputer can do in minutes what would take a regular computer months. That translates directly into faster innovation and quicker breakthroughs. Scientists also use supercomputers for climate modeling, simulating how the Earth's atmosphere will change over the next 100 years, which requires processing vast amounts of meteorological data. Drug discovery is another massive application. When researchers want to understand how a new molecule will interact with a disease target in the human body, they can use a supercomputer to run detailed simulations instead of waiting for physical experiments to complete. Materials science uses them to design new alloys and compounds. The military uses them for advanced simulations and defense modeling. The nation that controls the fastest supercomputers essentially gets first access to these breakthroughs. China gets faster artificial intelligence models, better climate predictions, and advanced weapons simulations months or years ahead of anyone else. That's not hypothetical, that's strategic advantage playing out in real time. It's like getting a running start in a race where everyone else is still tying their shoes. And this is where things get really complicated. So how does the Lineshine actually stack up against the systems that were at the top before? The United States has a supercomputer called Frontier, located at Oak Ridge National Laboratory, which was the fastest until now. Frontier could do about 140 petaflops, so it was already incredibly powerful. But the Lineshine is faster, hitting over 100 petaflops with better efficiency. That might not sound like much of a difference, maybe 20% faster, but in the supercomputer world, when you're at this level of performance, 20% is absolutely massive. It represents years of research and development. Europe also has advanced systems, things like Lumi in Finland, but they are still behind both the Lineshine and Frontier. Japan has Fugaku, which was once considered nearly state-of-the-art. These machines cost hundreds of millions of dollars to build and run. They require specially designed facilities with cooling systems, dedicated power infrastructure, and teams of engineers to maintain them around the clock. The Lineshine isn't just slightly faster. It represents a leap forward that shows China has caught up to or exceeded the world's best in this critical technology. What's remarkable is that this happened while the United States and other Western nations were focused on other priorities. But here's what this actually means for geopolitics. Let's talk about the real geopolitical implications here. When one country dominates supercomputer technology, they get a significant advantage in artificial intelligence development. They can train models faster, test more ideas, and iterate quicker than their competitors. China's national artificial intelligence strategy explicitly prioritizes becoming the world's leading power by 2030. They're investing billions into artificial intelligence research, and now they have the computational infrastructure to back it up. That's strategically significant for Western nations because artificial intelligence is going to define the next decade economically and militarily. It's not just about chatbots or image generators. It's about autonomous systems, defense applications, scientific breakthroughs, and economic competitiveness globally. The geopolitical calculation changes when China has access to more computational power than anyone else. There's also the critical question of supply chain vulnerability. Both the United States and China compete intensely to control the semiconductor manufacturing industry because chips are fundamental to everything from artificial intelligence to defense systems. China's ability to build Lineshine domestically, using homegrown technology as much as possible, represents real progress toward independence from Western supply chains. That's strategically critical for them. For the rest of the world, it means the competition for technological supremacy just became significantly more intense. The race for artificial intelligence dominance isn't theoretical anymore. It's happening right now, and infrastructure like Lineshine is how it's decided. But there's something important about what this means going forward. So what should you be watching for going forward? First, expect China to push for even faster systems. The Lineshine won't hold the top spot for long. Supercomputer development moves incredibly fast, and the next breakthrough is probably already being built somewhere right now. Second, watch how Western nations respond. The United States will almost certainly increase funding for supercomputer research and development. Europe will coordinate through research partnerships and collaborative initiatives. Japan will keep advancing systems like Fugaku's successor. Every major tech competitive nation understands they can't fall behind on this front. Third, Pay close attention to semiconductor supply chains. The restrictions Western nations place on advanced chip exports to China are becoming increasingly critical to this competition. If China can reliably source cutting-edge processors domestically, they'll maintain their advantage. If they can't, they remain vulnerable to sanctions and export controls. Fourth, keep your eye on the applications emerging from this computational power. China will likely publish impressive breakthroughs in artificial intelligence, climate science, and materials research in coming years, all powered by machines like Lineshine. These results will demonstrate why supercomputer dominance actually matters in the real world. Finally, remember that supercomputers are just the hardware. The real competition is about turning that computational power into innovations that transform entire industries. And that brings us to what this all means. Here's what you need to understand from this story. Supercomputers represent a key battleground in the global competition between major powers. They're not just impressive pieces of technology, they are strategic assets that determine who gets to the future first. China's Lineshine represents a significant change in technological capability and a reminder that the race for artificial intelligence dominance is very real and incredibly competitive. For people working in technology, artificial intelligence, or scientific research, this means the landscape is fundamentally shifting. Resources will increasingly flow toward places with the best computational infrastructure. For everyone else, it means understanding that how nations invest in foundational technologies like supercomputers matters. These decisions shape everything from the speed of medical breakthroughs to the capabilities of autonomous systems to how quickly artificial intelligence advances. The news cycle will move on to the next story, but this is the kind of development that quietly reshapes the world for years. China's back at the top of the supercomputer rankings, and that has implications rippling across artificial intelligence, scientific discovery, and global competition. Follow for daily artificial intelligence news and technology updates that actually cut through the hype. Thanks for watching.